In this video, we're going to launch a web server on an EC2 instance, and that web server, that website, will talk to a database to store and load data. That database will then be managed by AWS with help of the RDS service. And therefore, in the video, you will see how you can create a new managed database instance with help of the AWS RDS service, and how that instance could then be used by another workload, a website running on EC2, to load and fetch data. For this video, I do expect that you do have some basic AWS knowledge, that you know what the RDS and EC2 services are about, and in case you don't have that, you might want to check out my Cloud Practitioner course, which gets you started with AWS and provides you with a thorough overview of all core AWS services. In addition, the course also helps you pass your first entry-level certification, the Cloud Practitioner certification, in case you're interested in that. Now, for that video here, I prepared a basic website, a demo website, and of course you find a link to that website attached to this video. Now, this website is a very trivial website, but in the end there, in the data.js file, we do send some queries, some SQL queries to a database. So therefore, we want to connect a database that uses the SQL language. We want to use a relational database here. And we have some connection details about which we'll have to take care later. The rest of this website is pretty simple. I accept a couple of requests for different endpoints, different paths, and then we do different things. We're going to see it in action soon. Now, in order to run this website, we need an EC2 instance. But since this website needs a database, we need to create that database first. And we got a couple of options regarding that. We could launch an EC2 instance on which we run our own database server. We could launch an instance on which we install, for example, the MySQL database software, the MySQL database engine, and we run our own MySQL server on that instance. We could do that. And then we could have the same instance or another EC2 instance on which we run the web server that talks to that database server. The problem with running our own server is that we're fully responsible for it though. And I'm talking about the database server here. If you run your own database server, you have to take care about data encryption if you want it. You have to take care about backups, keeping the operating system and the database software patched, and many other things as well. You can do that and you might have the necessary expertise, but you also might not be willing to do that. It might be safer, quicker, and maybe also cheaper to use a managed service where you can easily start a database server and you don't have to worry about all these nitty-gritty details. And that's exactly what the RDS service is all about, which is offered by AWS. It's the managed relational database service that makes creating managed relational database servers a breeze. From inside this services page here in the management console, you can easily create a new database by clicking that button. And then you can choose which database engine you want to use. And since this is the relational database service, we got a couple of relational database engines here to choose from. And I'll go with MySQL because this app which I prepared here actually uses queries that work with SQL and uses a package that expects to connect to a SQL database. Now, once you chose your engine, you also have to choose the version of the engine you want to use, and here I'll use the latest one. And you can also select a template that then limits the options you have further down below. Limiting the options can make sense to, for example, ensure that the database instance you're going to launch will qualify for the free tier so that you're not paying for it. If you run a production workload, you of course might want different settings, but for this video, I'll choose the free tier option. Now, one option that is disabled now, for example, is the option to set up a multi-AC cluster. Multi-AC means multi-availability zone because, like EC2 instances, the RDS service and the instances you start with it are regional constructs, so the region you select matters. And you can create a multi-AC cluster to make sure that multiple database instances are created instead of just one. And those different instances are distributed across different availability zones, leading to a highly available database cluster. So that if one availability zone would go down, the other availability zones with those other database instances are still available. And this feature also ensures that data is automatically replicated between those availability zones and those different instances. And that's also why it does cost you extra money, because you're running more instances and you're getting this automatic replication. Now here we're using a single DB instance, so no multi-AC deployment, because we want to qualify for the free tier. For a production workload, you might want to use multi-AC clusters though. Now you also have to assign a database identifier and then some credentials, which will also be important for connecting to the database later. Here I'll assign a dummy password, which I want to use. And you can choose any password you want, but those credentials will matter later in the application code to connect to that database. We need things like the username and the password here. And here I'm extracting that data from environment variables. I'll show you how you could set those later, but you definitely need those credentials to connect your application to that database. You also have to choose an instance type, just as with EC2 instances. Now again, some options are locked because of our free tier choice, but we can choose from these non-locked options. And again, we simply choose a hardware profile here. It's not the same set of options as we have it for EC2 instances, but it's of course similar. We have a different amount of CPU cores and different amounts of memory. The network speed also might matter to you. And here I'll simply stick to the default choice, but for production workloads you can choose more powerful instance types, more powerful instance configurations. You also configure the storage because the database data is ultimately stored on a disk, and you can choose from different disk types, optimized for different data access patterns. You can choose the allocated storage you want to have here, and I'll use the lowest amount possible to stay in the free tier. And you can also enable storage auto-scaling so that if you're running out of storage, more storage is added to the hard drive automatically. I'll disable it here, but you could enable this for production workloads to make sure that you're not running out of disk space. Now the next step is also important. You need to choose into which VPC this database should be launched. And here it selected the default VPC. Now in another video I created my own VPC and I want to use that own VPC here. But that's optional, you can also stick to the default VPC. What's important though is that you should use the same VPC as you will choose for your EC2 instances later, at least if you don't enable public access for this database, and I plan to not enable it. If you do enable it, then this database can be reached from anywhere in the internet. You still need those credentials, of course, which we set up here. You still need that, but anyone can try to connect to that database. It's not entirely correct because you can also add a security group which blocks some traffic, but generally there is internet connectivity. If you disable this, then you have no public IP and therefore there's no real way of reaching that instance. And it would also be a good idea to launch that instance into a private subnet. Because whilst you want to reach the database instance from your other workloads, for example from the website running on another EC2 instance, you might want to make sure that there is no technical connectivity to the internet, so that requests from outside your VPC can't even reach the database instance. Therefore, it would make sense to launch the database instance into a private subnet, because then other devices, other EC2 instances, for example, that are in the same VPC can still reach the database instance, but outside devices, outside of the VPC, can't reach this database instance. Therefore, I want to use my own VPC because there I have some private subnets, but in order to tell AWS that it should create this database instance in a private subnet, I have to create my own subnet group first. And this can be done here on the left, and unfortunately I have to leave this creation wizard real quick here. I will create a new subnet group here. name it private subnets 1, for example, a group of private subnets, connect it to this VPC which I created on my own in a different video. Again, if you don't have that, you can skip it and simply launch this database into a public subnet in the default VPC. That's also fine. Here I'll choose my own VPC though. And then I will add the 2 availability zones, which I chose when I created my private subnets in that other video, and then add those private subnets. Now I quickly need to check which subnet IDs were used for the private subnets. And that would be this one ending with 80 and this one ending with 103. So therefore here I'll quickly select these 2 subnets here. So now I have these private subnets which make up this group here, the private subnets group. And therefore back here, when I create a new database, I'll quickly go through the same settings as before again, choose the engine and the version, the free tier, and my password here, and leave all the other defaults as they were before. Default instance type and storage, disable auto scaling, and choose my own demo VPC. Then I choose the private subnets group I just created, and I disable public access in addition, so that this database instance that will be created really can only be reached from inside that VPC. So only from that EC2 instance that runs the web server, which I will start in a couple of minutes. Now you also should add a security group to that database instance, which further controls which kind of traffic reaches the instance. The subnet choice and this setting here is about the technical connectivity. The security group is an additional firewall which filters out unwanted requests once they technically reached the instance. And here we can stick to that default security group or create a new security group. For the moment, I'll stick to the default one, but we'll have to tweak that security group in a couple of minutes. You can also choose which port should be exposed, but I'll stick to the default MySQL port here. You could also choose an availability zone preference if you had one, but here I don't really care. And therefore, as a next step, we should ensure that we choose password authentication here, so that other processes, other workloads, like the web server we're about to launch, can connect to that database instance with help of username and password. The other options are more advanced and require AWS credentials basically, or AWS permissions. Here we're going to stick to this default method. Now under additional configuration, you can set up an initial database name, and I'll simply go with demo1 here, but it's up to you which name you want to use. And then this default database will be created automatically for you on this database server by AWS. If you don't choose an initial database name, you have to create an initial or a first database manually by connecting to this database instance after it was created and running the appropriate SQL commands. You can also choose a so-called parameter group here, which is simply a group of database server settings, and you can manage parameter groups as part of the RDS service so that you can really tweak all these database server settings as wanted. Here, I'll simply stick to the default. You can also enable or disable automated backups, and here I'll disable it, but of course it would be a good idea to enable it for production level databases. And you can enable or disable encryption to make sure that database data is encrypted, so that if your database would get compromised, at least the data is encrypted. I'll disable it here, but again, for production databases, so production systems, you might want to enable it. Same is true for monitoring and logging. Here I'll disable all of it. And as a last setting, you can choose the maintenance window and whether patch upgrades for the database software should be downloaded and installed automatically. Here I'll enable it, but you could also disable it if you don't want that behavior. Though it is an advantage of a managed service that you don't have to worry about those patch updates. Therefore, I will keep that enabled here. And with that, we can create this database. Now that this database is being created here, we can switch to the EC2 service. because now I want to start that web server on an EC2 instance. I actually only want to start it once the RDS instance is up and running, but we can already get started here. And I will get started by tweaking my security groups. That's actually the first thing. I got a couple of security groups here, and if we quickly go back to the RDS service here in a different tab, then if we inspect the database instance that is being created here, we can see that it has this security group ending with 856 attached to it. Now, if we go to this security group here, we see that at the moment, this security group allows all traffic. Now, you could narrow this down to only allow traffic to that special MySQL port, because that's actually the only traffic we want. But I don't want to edit that default security group, so I'll create a new one, name it RDS1, give it a description like control RDS access or request access, whatever, and add it to my demo VPC, because the RDS instance that we started is part of that demo VPC. Now I want to add one inbound rule, and here I want to control that MySQL traffic. Or to be precise, it's the MySQL Aurora traffic targeting this port, because that was the port we had as a default, and we did not change that default when we started the RDS instance. So any requests reaching that port should be allowed if they come from a certain source. And the source I want to use here is actually the IP address range of my own VPC into which I launched this database instance. In my case, that's this IP address range. That's the IP address range I assigned to my VPC when I created it. Now, if you use the default VPC, that's not the correct range, then instead it's this range here that should be used if you're using the default VPC. But for my own private VPC, which I created in another video, that's the range, and therefore any request targeting port 3306 that's coming from a device that has this kind of IP address, so an IP address from that range, and that's therefore a device, a machine that's part of my own VPC, those kinds of requests should be allowed. Those kinds of requests should reach the RDS instance. Other requests should be blocked. So I create this security group, and once it is created, I want to add it here to this database. For that, we need to modify it, and we can only modify it after it has been created. Hence, I'll wait for the creation to finish so that I can then add my new security group, and thereafter we can finally launch the EC2 instance that runs the web server. So creation finished. Now I can click modify, and the only thing I want to modify about this database is really the security group that's attached to it. So here I'll scroll down to connectivity, remove the default security group, and add RDS1 instead. So this security group I just created. And then continue here and apply these changes immediately. So now that the instance has been modified and this security group is attached, we can finally launch our EC2 instance that runs the web server that will talk to the database. So for that, I'll launch a new instance, and I'll use the default AMI here, default instance type, so that we're free tier eligible. I don't need a key pair because I don't plan on connecting to this instance through SSH. And for the network settings, I of course want to make sure that I choose my own VPC. If you're using the default VPC, you can of course stick to that, but since I launched my RDS instance into my own VPC, I also want to launch my EC2 instance into that same VPC. Here, I want to make sure that I choose a public subnet though, and that auto assign public IP is enabled, so that this instance will get a public IP address. And for the security group, I want a security group where I don't have the SSH rule. I don't need that because I don't plan on connecting through SSH. But I do want that HTTP rule because I do run a web server on that instance. Therefore, I want HTTP connectivity. Now, I don't need to change anything regarding the storage, but I do want to pass some user data to this instance, a script that should be executed once the instance boots up, or after it started, to be precise, to initialize the instance. This user data script is also provided attached to this video, and in that script, I install some software, Git to download my code, Node.js to run the code with Node.js. And very importantly, I then also start the Node.js server here, but I set some environment variables first. Now that's one way of passing data to that software, to that application that's running on the instance. I'm talking about these environment variables, which are red here, which are used to connect to the database. The environment variables I'm setting here are the address of the database, the username, the password I assigned, and the name of the default database. And you should use your values here. I'll also update some values in a couple of seconds. I want to say that this is just one way of providing that data. You could also use AWS Secrets Manager as an alternative, add some special code to your application to use that Secrets Manager API, and then manage your secret values, like the database username and password, through that extra AWS service. I do introduce you to Secrets Manager as I do to all the other core AWS services in my AWS course, which I mentioned earlier, but here for this example, we'll stick to good old environment variables, which are defined here right before the web server is started. Now I do need to update some values though. For one, I chose a slightly different password, and you should of course use your password here. I do use admin as a username though, and demo1 as a database name. And for the host, for the address of this RDS instance, we should go to that instance. And here under connectivity and security, you can find this endpoint. And that's the address of this instance that can be used and that can be reached from inside that VPC. If you would have enabled public access, it could also be reached via the internet. Here, I want to add that as my host here. And therefore now, with all of that done, we can launch this EC2 instance. Whoops, I forgot a source here for this HTTP rule. Here I want anywhere as a source because anyone should be able to send requests to this web server. But with that, I can launch the instance. And now this EC2 instance will start up, will download the code for this website, will start the web server, and the web server will then connect to the database, and then we'll be able to visit this website, and under the hood, the data will get stored in the database and will be fetched from there. So let's simply wait for this startup process to finish, and I'll also wait a couple of minutes after the instance is up and running to ensure that all the software has been installed and the web server is up and running successfully. Now here the EC2 instance is up and running, and therefore I can grab this public IP address. I have no domain name here because I haven't enabled the respective feature when I created my own VPC in a different video. But I can grab this public IP address and send a request to it. And we should see the website there, and we can share some message here. This is a test, a statement, and under the hood, this is written to the database and stored in the database. And therefore now we successfully deployed a website that talks to a database, and we also created that database server on our own, with help of the RDS service. Now, to clean everything up, I'll terminate this instance, and then I'll also go to the RDS service page and get rid of that database instance so that we're not paying for that anymore. It was part of the free tier, but I want to make sure that I don't forget about it. Hence, we can select that database instance and delete it. We could create a final snapshot to save the data so that we could recreate the database based on that data in the future, but here I don't need that. Hence, I acknowledge that my data will be lost, and then I delete this RDS instance. This will take a couple of minutes, but thereafter it will gone, and with it, your data. But that's how you can get started with the RDS service.